everybody. Thank you for joining us today in this Riskified technology meetup from legacy to kingdom. Today, Drorit and I are going to talk to you about a very interesting journey that we've been through at Riskified, in which we enabled some big architectural changes and taking it step by step using some very interesting design patterns that we've formed in-house and that enabled us to move forward with a very big and interesting change. So if you have any questions during the talk, feel free to send those questions in the chat. We will stop in the middle and in the end to read those and to answer your questions. So feel free to write them in the chat and we will refer to them later on. So just a bit about us before we start. I'm Eliav. I've been with Riskified for the past 6.5 years now. I'm part of the account team, which is responsible for everything that is related to the customer lifecycle for our clients. That means, for example, that we verify the validity of logins to our clients' accounts. And I'm originally a classically trained musician. That means my BA is actually in music, and I play early guitars and lutes, which is practically a plucked instrument from the 17th century. That makes me a very big nerd in another field rather than programming. I also love everything French. I love speaking French. I love being in Paris, which I cannot do at the moment, unfortunately, and basically everything that smells like French culture. Yep, so that's me.
Hi, everyone. My name is Drorit. I'm a technical lead in one of the backend teams at Riskified. I've been with the company for the past 6 years now. I have a background in hardware engineering, and I enjoy doing yoga, and I love working out. Right. So, sorry. Yeah. So I'm going to share with you a short overview of what we're going to talk about today. Eliav and I will start off with a system overview of Riskified, a little bit about the early days versus nowadays. Okay, this is just like kind of give you the background and a little bit about reasoning about some of the decisions that were made at certain points in time. Then we're going to talk about some of the growing pains we've had and difficulties we've experienced during that transition, all right, from the early days to nowadays. And then we're going to show you a cool solution to one of those problems that we mentioned. That's called logical separation. And we'll conclude with showing you guys a step-by-step simplified solution implementation, of the main design pattern that really enabled us to gain logical separation.
Right, but let's take a minute just to talk about Riskified just before we dive in. So what exactly do we do and why it's such a great place to work at? So we've been around for the past 7.5 years now. We have more than 500 employees in 3 continents. We have offices in Shanghai, Tel Aviv, and New York. And we've raised more than $229 million in 5 funding rounds. Basically, our clients are e-commerce merchants. We are focused on enterprise merchants mostly, and we are offering a lot of services around enabling e-commerce for them. Our main product is called Chargeback Guarantee, and we're going to talk about it in just a bit. And we process more than 1 million transactions per day. That number might triple itself, for example, on the holiday season. But basically, that's we're pretty much at high scale at the moment. So we have a lot of merchants from a lot of industries. Just to name a few names, we have Macy's and Booking.com and Foot Locker, some names that you might recognize, and a lot more in many industries. So what do we do, actually? So our main product is called Chargeback Guarantee, and what it does is basically, maybe some of you know the feeling that you wake up and you see some unrecognized charge on your credit card billing, and then you say, I did not purchase that kind of purchase, and you call the bank and you cancel it, and then you get the money back. So the merchant is the one who's getting the liability to give the money back to you. So, sorry. So what we do is that we take away that kind of pain from the merchants and allow them to focus on selling and making their businesses, and we focus on everything that is fraud related. So we review the orders for the merchants, and we simply tell them a very simple approve or decline response in no time, and that allows them to go on and know that they're covered for everything fraud related. So that's just a bit about us, and we will talk about what happens inside this kind of flow in just a bit.
Right, so a system overview. I'm gonna share with you guys sort of a view of Riskified's early architecture, and then I will show you the current architecture, and then Eliav and I will describe some of the difficulties we've had in really making that transition between the two. And then we're going to talk about like a cool solution that we found for one specific problem. Okay, so this is Riskified sort of early on architecture. As Eliav said, what we do is we do fraud analysis for e-commerce transactions. So things start off when we get the information about those transactions or orders. We get them in the form of a JSON, which used to hit a monolith, okay, running Ruby on Rails at the time. So it hits sort of like a Rails controller, let's call it like a module, an API module. And then using an ORM, we would persist the data in a PostgreSDB, okay, it's a relational database. And later on, an analysis module in the same monolith would use the same ORM to fetch the data out of the database and really use it for the fraud analysis, okay? And now this is where we're currently at, okay? This is the current architecture at Riskified. So we still have JSONs coming in with the order data, the order information. But now instead of hitting a monolith, it hits sort of like an API microservice. That microservice does what it does, and then it outputs its data to a Kafka topic, a Kafka broker, which later on an analysis microservice uses. It consumes the data and uses it for the fraud analysis, okay? So this is just a standard breakdown of a monolithic architecture into a microservice one. But we're not really going to get into that today. We're not going to discuss the pros and cons of a monolith versus a microservice-oriented architecture, because that's not really the topic of our talk. Really what we want to focus on are some of the difficulties we've had and specific one difficulty that we found a cool solution for.
But Drorit just showed us like where we want to be, where we wanted to be at the time being, right? So it was pretty obvious to us that we cannot just wake up one morning and make that kind of change. For any kind of organization, breaking down a monolith, for example, is a big change that you want to make sure you're doing it right. And you want to make sure that you're prepared for that change and that you're not going to break anything and upset your customers. So it was obvious to us that we need to plan carefully in order to execute successfully. And the first thing we did was to ask a lot of questions. We talked, which is obviously a very good way to start such a change. We talked between the teams and asked, what do we need to take care for? So let's see some of the questions that we've mapped towards that kind of change. Being very data-centric, our services each encapsulate some part of the data that we're processing. So the first question that we've asked ourselves is, what is the data of the microservice to be? The API team wanted to extract a microservice. What exactly is the data it encompasses? Where does it start and end? What exactly is its data model? Do we want to keep the same API when we're going to work with it? For now, we're using a Postgres database for all means. And when we're going to be on the other side and extract a microservice, do we want to keep the relational model, or do we want to move on to something else, maybe a document-based database, for example? Hint, that's like one of the changes that they want to introduce. We're also seeing a lack of boundaries. So right now, working in a monolith, everybody can do pretty much everything. We'll see that in action in just a bit. So who exactly can write and read data to what kind of tables? When you are breaking a monolith, this is a very important question that you want to be asking yourself in order to not to break things up and make a mess. And another aspect of that is that there is no clear owner, right, of the data at the current point, because anybody can do pretty much everything. And when some issue arises with a certain aspect of the data, who exactly takes responsibility for that? So these are all kind of questions that we've mapped. There's a ton more, but these are going to be the main ones for our talk today.
Right. So if we really want to answer all those questions, we really need to know the data. Okay. So let's meet order. Okay. So order is Riskified's main domain object at the time. We receive it over HTTP as the payload of the requests from our customers, right, the merchants, our shops. And it contains a lot of submodels, which is really the data, anything you think of when you think of like an e-commerce transaction, right? So maybe the products, right, what they're buying, and information about the customer itself, maybe their name and email address. We have here like a small example of what the data looks like when we get it. So it looks like a simple JSON. You can see here it has an array of products and and maybe some information about the customer. I'm sorry, and some information about the customer, as I was saying. Okay, just a simple JSON. Obviously, in real life, it has a lot more data points, but this is just like kind of give you an example. And what we do with it is the first thing, as I said, we persist it in a PostgreSDB, which is a relational database. And so one JSON is really split into dozens of tables, okay? And later on, the data is accessible via the same ORM, similar to what I've shown you in the more high-level view. So we have here an example of what an ORM usage looks like. It's pretty standard. This specific example is active record, which is what we used at the time because we were running Ruby on Rails. So let's say I want to create a new entry in orders table. So I have an order ORM object, and I do .create on it, and I pass it the information I want to persist. Okay, the same data that I've extracted from the JSON. The price, the shop, etc. And I get back an order object, which later on I can do .update on and update really any attribute that I want. For example, once the analysis it does what it does and it decides, okay, I want to approve this order, I can just update the decision field and say this order is approved, okay? And this is what it looks like in the database. So it's just a standard relational data model. We have one entry in orders table per order with an ID and the price, etc. And an order might have multiple products, as you've seen, so it can have multiple entries in products table, which has a foreign key on it, which is the order ID. And this is how they relate to one another. So an order has many products, and a product belongs to one order.
Right. So this is pretty much what we've modeled intuitively, right? Like every organization started off, and the best thing to do is like to go with the intuition. We did, we're talking about like 7 years ago, a very small dev team. Everything is pretty moving fast. And with time, we're seeing what I'm sure all of you have seen. Stuff changes on the requirements, and the world around us is evolving. Maybe product is coming in with new requirements, and maybe our customers are asking for new things, et cetera, et cetera. Our now analytical needs are growing, and stuff changes. And guess what? You need to react to it, right? That's the fun part. So we've seen a lot of stuff in Riskified over the years, but I'm gonna focus on just one aspect. One of the things that we're seeing is that with time, order-related data is now starting to flow into the system from other sources rather than the API. So what Drorit just talked with us about is how information is coming to Riskified from our API with the clients. But Moreover, we have suddenly maybe additional email information coming to us from our web application, in which the merchants might manually add an email address which is associated with a specific order. And I'm going to focus on this example a bit because it will accompany us for the rest of the slides. We also have our own storefront beacon. What exactly does that mean? We run sort of a beacon on our merchants' websites, and we're collecting information about customers during their sessions and browsing their websites. So when analysis kicks in, we have a lot of much more deeper prism about the customer's life cycle. So we know much more, we know much better to analyze it. So we get like maybe a lot of IPs that they've been using during the previous session before the purchase. So this gives us like a much deeper view of things. That's just a side note to make you understand that we have more IPs associated with an order rather than the one that came in from the very purchase. So what we did is to simply take those IPs and pour them in the very same IP table that we had at the time. So we had an IP table, and we are now seeing IPs that are coming into it that are not from the API. And what you're seeing here is just one example of order number 13, and it has 5 IPs. You can clearly see each IP is different, but it is also annotated with a different source. So if an IP came from the API, it is annotated with source API and vice versa for the beacon. And what that gives us is the ability to discern where the data came from. But basically, it's the same table, very, very simple design. I want to stress a bit about that point, that this is the design. We could have done many other things to solve that kind of growth, and we chose to do that because at the time this was one of many issues that we had to react to, and this was the best decision to make us grow fast, allow us grow fast, move on as a small startup. And also, you don't have exactly like all the knowledge at the time. You just make the easiest decision, and then you reassess it a bit afterwards, which is I think it's a great way to work. And what we're talking about today is going to be evolve a bit around that kind of design choice.
Yeah, Eliav, I completely agree. I mean, at the time, this is really what enabled us like to accelerate and grow really as fast as we needed, because we were really growing.
Yeah.
Faster.
So the first thing we did when the API team wanted to break away to their own microservice, this kind of stuff was like, if you remember the question that I showed in a few slides back, this really rings a bell, right? Suddenly we have like a mix-up of ownerships of information that people are using in the same table for different sources, and different teams are writing to it. And when we want to extract the microservice, this kind of stuff is becoming an issue, maybe. So the first thing the API team did to start this kind of big project of breaking down and departing from the monolith was to map ownerships around the whole data organization in Riskified. So what does taking ownership actually means in such a context? Basically, something very simple. If you remember, we had the source column, right? So we simply went on with that kind of logic and mapped it between teams which are maintaining services. So we knew that API sourced rows are under the responsibility and ownership of the API team, and they will take those rows with them to their new microservice to be. And similarly, the beacon annotated rows are under the responsibility of the front-end team, right? So this kind of thinking is the very basis of doing those things. We had a lot more models, as Drorit said. We had like dozens of them. So we did those kind of talks. We knew how the data should be split ideally. And this is the very first thing we did to start off. Let's see if we have any questions so far. If you have anything, feel free to send it. No, I think we're good for now. So if you have anything, feel free to send it in the chat. We will stop towards the end to review more questions. So please feel free.
Right. So, sorry. Yeah. So continuing that taking ownership approach, I'm gonna change the perspective, and I'm gonna talk more from the API team's perspective. I'm a technical lead in the API team. I don't know if I mentioned that. So, but just know that similar measures and steps were taken by other teams. But this is just like sort of like the example that we're talking about today. So meet API order. All right. Sorry. So it's meant to serve as the main model for the API microservice or gateway to be. Okay, as opposed to the order, which was the main model of Riskified, okay? It only contains data that falls under the ownership of the API team, which really means that it doesn't contain like the beacon IPs, okay? That doesn't come from the API, so it's not going to be in the API order. And it's aimed to be remodeled as a document. And now this is where it gets hard, okay? Because we're moving away from a relational data model to a document one, which is going to be stored in more of a key value store. So you can't really do all of those things that we used to do on the data. I will show you a bit later on how we really approach that change. This is a very significant change, okay?
Mm-hmm.
So, sorry, yeah. So just like a short recap of our high-level plan, because we have a little bit more information now. So we have the JSONs coming in to the API microservice, which, by the way, is written in Scala. So that's really not doesn't make that much of a difference, but just a side note.
Yeah, things have changed a bit in the last 7 years.
Yeah, which is a shiny new service written in Scala. Its output is now called API order. It's produced to a Kafka topic, and then the analysis microservice consumes the data and uses it for analysis. Now, you might stop and think that the analysis microservice used to have access to also the beacon data, right? So what now? But just as I said, other teams were taking the same actions and making their data accessible. But the point is they can really decide for themselves how to make it accessible. For example, maybe they want to persist their data in a MongoDB, or maybe they're fine with Postgres and want to leave it there. But really the point is that with what we're going to show you, each team could really decide for their own, and we really were able to gain that separation of data.
I think many organizations are like seeing stuff like this, right? You start off like, and maybe in a monolith, and then you split, and then each team and maybe each group is like taking their own decision. And I think it's very natural and very healthy kind of approach to software development.
Yeah, it's not trivial. Yeah.
Yep, always a project. So it was obvious to us, as I've said, that we cannot just do it like in one day, in one morning, wake up to this shiny new separation that everything falls into place and everything is great. And we knew we need to work harder beforehand and to prepare everything so we can do this kind of change in a responsible fashion and not break things and not upset customers. And what we came up with was we said to ourselves, what if we really worked hard before the physical change, before we extract the microservice, and make it as if we are separated within the same code base. So this is what we call logical separation. We separate concerns and domains, but with a logical approach first, before the physical approach. So what exactly does logical separation means, hands down? So, sorry, oops. So with logical separation, data is staying in the same database tables, right? We are not changing anything physically. We've seen the IP table is going to stay just the same. Nothing changes around that. And what does change is that querying and modifying information is now restricted between owners in a logical way. That means that beforehand, everything was possible because you're just using whatever ORM you're using, which I'm sure rings a bell with many of you. So now what we're seeing is that we only change data, we only access data in a much more monitored fashion. And for us, it was pretty obvious that logical separation is only a stepping stone towards physical separation, right? We're talking about breaking down a monolith here in this example. And this is exactly what we're trying to achieve, right? We're logical separating things in order to make the physical separation much easier when we get to it. So yeah. And the last thing I want to emphasize is that it was pretty clear for us working with ORMs for a long time that this kind of change is not the ORM responsibility, right? Because ORMs are great, I'm sure you know it, ORMs are great for accessing the database, mapping the objects back to us so we don't get like something which is not workable with, and it's not designed to make domain boundaries very clear and to allow this kind of intricate, very, very delicate changes to code bases. So it was pretty clear to us at the point that we needed our very own layer on top of the ORM. So we're coming to the point that we have the DB and the ORM, and on top of it, we have our own layer. And we chose to call that layer Mediator. So now it looks like this. We have the database, the ORM, and the clients, aka calling sites in our code base, are no longer talking to the ORM directly, but rather to the mediator, which is a sort of a concept that we came up with, which blends several design patterns and is our like aha moment, our suggested solution. It blends some of the proxy pattern and data access object and data transfer object and maybe some repo pattern as well, and some of the mediator pattern, the classic Django 4 mediator pattern. So it's kind of like the original pattern on steroids. It's not the classic pattern, we know it, but it's just like the name which we found best fit to solve this kind of problem. So keep in mind that it's not exactly what you might remember from that book, but some like hyper version of it, right? Yeah.
Yeah. So we're gonna walk you guys through some step-by-step implementation, simplified implementation of the mediator concept, okay? And really with every step, we're gonna show you what we gain, okay? What we aim to gain from, okay? So the first concept, just I think it's the basic one. We wanted to first wrap the ORM. We're going to show you some code example. Specifically, this is Ruby because this is what we worked with at the time, but really it's language agnostic, can be and maybe should be implemented in any language. So let's assume we have like a class called ORM, okay? This will be our ORM for today. It has a lot of functionality. You can see 3 examples here, but just note that there can be hundreds. For example, with Active Record, there really are hundreds of functionalities. So you can find by any attribute, you can delete by any attribute, and also you can update any attribute, which is really very compatible with the relational data model.
Right.
And it's like a very broad API, okay? Think of it like the contract between your data and your users, like the data users, the users of the data. And now this is a very broad API, okay? And we're gonna go back to that a bit later. Okay, so now we have a class IP, which extends that ORM, and that will be our ORM over the order IP table that we've showed you in the example before. And this is what the mediator will look like. Now it has an instance of the ORM that it wraps, okay, the IP class, and it has the exact same functionalities, okay. So it also has a find by anything method function, and it just under the hood it calls the ORM's find by with the same attributes, okay. So nothing too fancy here, just a wrapper for the ORM.
And by doing that, we obviously did not gain much, right? We still like just delegating messages to another class, another instance. But the first thing we did want to gain, and it was very obvious to us that the journey starts here. What we wanted to gain was to change the return values, right? We want the information coming back from the ORM, from the database, to us to be a simple, immutable data object. Instead of the method-rich and information-rich object that the ORM is bringing back. Some ORM are different in that, but some are really like, might be very, very, very large objects. So how did we do that? Very, very simply, we introduced another class which represents the table in question. For example, the IP table had an IP data class, which looks like this, right? It has the IP, the order ID that we've seen before, and the source, which is another column in the table. And we've introduced a mapping upon the find-by function in the mediator in order to take the ORM response and simply map it into our very own struct. So we're losing by purpose, by intention, the object that's coming back from the ORM and returning the IP data that we are in charge and in control of, right?
Right. Gotta love immutability.
Yeah, gotta love immutability.
Best friend, your best friend, yes.
Yeah.
Another important thing we wanted to gain from our mediators is really a stricter API definition per model, okay? So I'm gonna show you guys what that looks like. So remember the ORM class that I've showed you before with really the 500, maybe hundreds of functions and a lot of functionality on it? As I said, this will be the contract between your users and your data. This is what you're like obliged to, okay? So if you think about it, if, as I said, the API team, they wanted to move away from a relational data model, which really allows, right? It allows you to update any attribute and to search by any attribute. And they wanted to make a transition to a more document-based data models, which is a little bit more, not exactly, but a bit more like a key value one. You can't really search by anything now. You have a specific key that you want to search on, for example, the order ID, right? So this is what the mediator will look like now. So instead of having a find by anything method, we will expose a find by order ID, which is just the key. This is the key that we'll have in our key value store. And under the hood, it just calls the ORM's find by, the broad find by, but it limits the scope of the search to the order ID only, right? So now you can only search by a specific key. You can't do all those great things that a relational data model and an ORM provides. And you might also notice that I've dropped the update function altogether, right? So maybe the API team decided that they don't want you to do any updates on their data. They just want to be able to create new items or new documents, but never to update an existing one. So we can really do that with the mediator because we can take away and leave only the functionality that we want to expose.
And by now, we've only seen some decoration around contracts and signatures and API, but how do we actually gain logical separation by mediators? So this brings us back, this brings us to the next point, actually, which is scoping whatever available data the mediator is handing back or allowing access to. So we know that each domain might access different rows in the database. Remember, we remember the IP table with two different kind of sources. So what's happening now is going to be like sort of the pivotal moment. So what we did was like to map those domains, and each now has its own IP data. We saw the beacon and the IP sources. So each is getting its own class under their own namespace. This is how you do namespaces in Ruby. So module API has IP data and module beacon has IP data, and they're both the very same, but they represent two different data structures that in the future might come from, right, from two different microservices or whatever. And yeah, they look the same, but if you might have noticed, I dropped the source attribute because it is no longer needed. Because if it's an instance of API IP data, it can only represent API sourced IP records, right? And same goes for beacon. So it's no longer needed. It's kind of like a discriminator that is built in to the very class that represents the record. So, right, we have those data objects. How do we use them in a mediator to help us? So with the duplication of domains, we get duplication of mediators. So the API mediator, IP mediator is now a thing. We have an IP mediator for the API namespace, and it exposes the find by method with a strict, hard-coded lookup by source API. Because under the hood, the data has the source API. The ORM doesn't know anything about the layers we're talking about here. So we're making it clear that by working with the mediator for the API, IP mediator, you can only get back API sourced records, which is, I think this is like key here, right? This is exactly what we wanted to achieve. So you can't just do anything to the IP table anymore. You can only do stuff that is related to API sourced records. And same goes for whatever functionality. I'm just showing the find by just for convenience. And as you can imagine, the very same thing happens for the beacon IP mediator, which is hard-coded by choice to the source beacon.
So let me just, I just want to emphasize something about this concept that Eliav talked about. If before the analysis class or any other really class would be able to fetch all of the IPs related to a specific order in a single query, right? There was no mediator, just like a ORM.findBy. Now you have to make 2 queries to the same table, right? Now really this is where we took a hit in performance, okay? But if you think about it, this step needs to be done. It has to be done because today those are 2 queries to the same table, but tomorrow it's a query to the table and another, I don't know, maybe query to some other completely different data store. Okay, so this is a step that had to be taken. This is really
that kind of optimization didn't really exist beforehand. We were just enjoying from it, but it kind of like needed to go, and it's like a mind shift that you need to do, right?
Yeah, you gotta do it. All right, another cool thing that we were able to obtain from our mediators is really sort of like a permission mechanism, but not really permission like with passwords and stuff, but I'm gonna show you guys what it looks like. So let's say I have the API module, which is really like where the API team is coding and everything, and they have their own mediator for the API IPs, for their data, with all of the functionalities that I want the API team to be able to perform on their data. They can search by it, they can create it, and they can delete it. And also they have another mediator for the beacon IPs with the functionalities that I want the API team to have over the beacon IPs, which is only a findBy, okay? So like a read-only permission, right? They don't even have the functionality of creating and deleting IPs that they don't own. It's not their data. So really using mediators, we were able to restrict and sort of like implement a permission mechanism.
Yeah, I think it's like very, it takes a lot of goodwill working in such fashion, right? Like you need, it sounds like people need to communicate, and I think this is key for such projects. And what you show here is that basically you're just like, you know that those domains are going to separate and you're preparing it, which is, I think, the key concept of what this whole talk is about.
Yeah, I completely agree.
One last thing we wanted to show you guys is that, you know, it all looks lovely and perfect, like kind of depiction of our world. But in reality, as Drorit said a few times, ORMs and any like strong library might have a very rich interface, right? And lots of functions, lots of methods running around. And guess what? People are going to use those methods. And I'm sure you guys felt this. Like you're working with some library and people are using it and you're trying to migrate away from it. And it's hard because you're kind of like bound to those usage sites. And what we did was to basically tell people, right, this kind of functionalities might need to go because the API team wants to be able to allow you to find orders only by order ID, as Drorit said. But some teams might have been looking for orders by the IP. And this functionality is going to go away. What we're doing is we're exposing it ad hoc, like we're just exposing find by IP for that team, and we are annotating it with a logger warn, which says this functionality is in deprecation. So you might ask yourself, what's going to happen in like 3 months time? What are you suggesting for that team? And the answer is, well, they need to find their own solution and create their own materialization of the data in order to serve that kind of functionality that they're striving to have. So they might consume it and store it in their own database of choice, in which the IP is the key or whatever choice they make, but it is no longer supported. This is a kind of mind shift again that you need to make, because it's a much bigger change than just having everything available.
So after we worked so hard and gained logical separation, we want to show you guys what's the next step to really gain that physical separation, and show you guys how the logical separation did the heavy lifting and really brought you like one step before physical separation. So this is where we left off after the logical separation. We have the database with the ORM over it, and then the mediator between the ORM and the clients. And let's say tomorrow morning, I'm set up with the new data store containing the API order, and I can just do this. I can just point the mediator to bring the API data from the API microservice. Now, just know that as long as I didn't break the contract between the mediator and the client, then I'm all good. And I didn't break that contract because I broke it a step before during the logical separation. Yeah, there's no way around it. I mean, you're breaking really your data's API. But really the logical separation allowed us to do it in a very controlled manner, step by step, not just in one day, really make a very scary transition.
Yeah, it kind of reminds me of, I think it's a Martin Fowler mantra, work hard to make the change easy. So it means like you do the heavy lifting before, and then like when the pivotal moment comes and you need to make the supposedly scary change, right? Like go to the new microservice, then it's just like that.
Yeah.
And I really like what you did there with separating this in such a responsible and careful fashion. I think many can relate to that, right? It's a pretty cool move.
Yeah, I agree.
Right. So we don't have any questions. You guys, if you want to ask anything, so this is a good time. We will take a recap just to move on, see what we've talked about today. So it's just like to sum things up. And if you have any questions, feel free to write them now or contact us later. So what we've seen today is, for me, one main takeaway is that it's probably always a good idea to wrap the ORM you're working with, and honestly, any library that is like very large and rich, because again, as we've said, it's a very big obligation you're taking, and you can like restrict it by doing that.
Another takeaway for me is that it's never too late to set boundaries between domains and owners, right? So like, we could have said, okay, we have a table containing the IPs, so probably maybe we should make that our domain. It would have made things easier for us, but no, we knew it didn't make sense for us, and we weren't afraid to like put the boundary right in the middle, right, like cut it through the data. And I think we really showed you a cool way of how you can do that.
Pretty much in any domain. I think this is a very general pattern that is like we've evolved here and showed you guys. It's not really Riskified specific at all.
Yeah.
And one last thing that we've seen is that how logical separation specifically helps, as I've said, as a stepping stone. It's just an intermediate step towards that desired physical separation, which represent a more mature architecture. So like do this kind of changes and do them in a responsible fashion, and don't be afraid to like do the heavy lifting work prior to the pivotal moment.
Don't have one scary day.
Yeah, don't have that scary morning.
Have a lot.
Right. So that's pretty much it. Thank you guys for coming and joining us today. If you have any questions, feel free to reach out to us over email or Twitter. And we also have the Riskified Technology tech blog which contains a lot of cool articles about lots of things. So thank you very much and have a great day. Bye-bye.
Bye, everyone.